This is probably going to be a long video, so let me start at the end with the TLDR. Where I'm going to get to is using language models, which is the sort of technology behind tools like ChatGPT in Scratch. For example, I'll be able to ask the Scratch cat something like, who were the Tudor kings of England? And get back an answer that I think that's right. I'm not going to commit to that. I haven't checked, but it's the right sort of thing. And I can ask something more opinion based, like, should white chocolate really be called chocolate? And I can get an answer that at first glance that looks like it's the right kind of thing that I was looking for. This is where I'm headed. And if you just wanted to see that doing generative AI in Scratch is possible, then you can probably leave me here. But I hope you're going to stick with me because I think the interesting bit is the journey for how you get to this. So I will start from the beginning by creating my first project. If you've not heard about machine learning for kids before, which seems unlikely because I hardly shut up about it, it's a free website that helps children to create a wide variety of types of machine learning technologies. Children can use machine learning to recognize things like text and images and sounds and numbers, or to predict things. But the option I'm going to be using today, the new option, is using machine learning to generate text. Uh, so that is this option here. I'm going to call my first project Volcano Expert because I'm going to be getting it to generate text about volcanoes. Um, so the use case here is generative AI, getting artificial intelligence to generate something, in this case, text. Um, and you've almost certainly heard of it. It's the most widely talked about form of AI today. So this is my new project. Our aim here is to understand a bit about the technologies that makes this possible, and I think it helps to do this in a few stages. First up, I'm going to be creating a toy language model, and the benefit of creating a toy language model is that it's so simple. You can understand exactly how it works. You can see what it's doing with text, and it will be text that you provide yourself. All of this will give you an introduction to the concepts, which is a great place to start. And like I say, it's good to do this in stages. So I'll be going through a couple more stages, but I'm going to start with this idea of a toy language model. The core idea here is that I'm going to use the computer to look for patterns in the text that I give it. It'll look for which words follow which other words and how often that happens. And I'm going to use those statistical patterns to generate text by using those patterns of what normally comes next to choose the next word and then the next and then the next. So the starting point is I need some text to look for patterns in, what we call a corpus. Now, for my model to generate text about volcanoes, I'm going to give it some documents about volcanoes. So I can click on Add Text. Um, I'll call this document Volcanoes, and I can paste in some writing about volcanoes. Now, it's a bit time consuming to write this stuff by hand, so it's easier to add files. So I can click on Add File and upload this file with text about the volcano Krakatoa. I've got a few other files with interesting volcano info. I've got one about where they are in the world, one about the structure of a volcano, and a third one about what happens when they erupt. Another useful source is Wikipedia. So I can search for pages about other famous volcanoes and add those pages to my corpus. So I can look for the page on Mount Etna. And that gives me loads of text with the history and details about it and the geography and all sorts of stuff. I can tweak it if I want. So like this stuff at the end is a bit noisy, so I'm going to delete that. But otherwise, this page looks good. And I can do the same for some other volcanoes like Mount Vesuvius. I think that's how you spell it. Yep, there we go. I'll add that. What other volcanoes? We've got Mauna Loa. And maybe one more. I'll go with Mount Kil. Testing my spelling again. Kilimanjaro, I think that's right. There we go, brilliant. That's enough for now. I mean, actually, this is more than enough. I got a bit carried away showing the different ways of adding documents. You can get started with less than this. So the model is going to be generating one new word at a time. And at each point, it's going to use the most recent text that it has so far. The patterns it'll find in the documents that I'm giving it is how it's going to decide which word should come next. But how much of the text that it has so far should it use to make that decision? Now, this is a bit like what we would call a context window in a real language model. Let me switch to some slides to explain this bit for a minute. Imagine the computer needs to choose a word to come after the. Which word should come next? Now, with a small amount of context, this is really difficult. What normally comes next after the word the? Well, it's really hard to know. It could be almost anything. Now, with a bit more context, it's a bit easier. So what normally comes next after sat on the? Now, you'd probably choose something like chair, sofa, seat, something like that. With a little more context, if you were given the cat sat on the and asked what word would come next, maybe now you would choose mat. The amount of context changes the word that you pick. The more context you have, the better choices you can make. But when a computer's doing it, the more context you have, the more complex the language model needs to be to handle it. So going back to my project, I need to choose the size of the context window. Now I'm going to start with the smallest size because I want to see what kind of effect that has, and then I'm going to come back and increase it afterwards. So here are the words that the computer found in the text that I've given it. I can see that the word the was the most common word in the documents that I collected. It came up 1,696 times. And of all of those 1,696 times that the word the was in the documents, what came next? What was the word after the? Well, 68 times it was the word volcano. The volcano was found 68 times in my corpus. 57 times the next word was summit. The summit was found 57 times in my documents. 46 times the next word was mountain. The mountain shows up 46 times in all of these documents up here. What other words were common? If I scroll through the list, I can see eruption. Eruption was common. It came up 157 times in my documents. And of all of those 157 times, what came next? What was the word after eruption? Well, 18 times, eruption was the end of a sentence. It was followed by something like a full stop, an exclamation mark, a question mark, something like that. 14 times, eruption was followed by of, eruption of. You get the idea. Now, this is not a full list of all the words in the document. This is, I mean, that would be a much, much longer list. This is a sample. It's a sample of the tokens in the documents. The idea of this is to give me a bit of a feel for what the computer has done with those documents that I've given it. So I'm going to move on. Click next. Right. So how do we use these patterns that the computer has found? How do we use these patterns to generate text? How do we use these patterns to choose the next word to generate? Because we found lots of options, but of all of these words that we've seen come next, how do we make a choice of which one should come next? So we've got a couple of options here. I'm going to start with top P, which is this one here on the right. Top P is how I can describe which of the words that came next should be a candidate. So let's go back to eruption that I was looking at before. So remember, it came up 157 times, and it was followed by words like of and in and was and occurred and so on. Now, with a high top p-value, all of these are candidates. That means that when the computer is choosing the next word to generate, if it's got eruption it can pick from any of these, anything that came after eruption in the documents that I collected. But if I lower the top p-value, as I drag it down, I move the cutoff. As I lower the top p-value, some of these words are going grey. They're not candidates anymore. So it can only pick from the words that still have this green bar. So as I change the top p-value, the cutoff point moves. Oops. If I change it there, you can see as I start to get lower, some of these words stop being candidates. I've moved the cutoff, and now only these are options. The choice I'm making is, how do I want the computer to generate new text? Do I want to choose the next word by sticking only to what comes very often, like this, keeping it low? Or do I want it to have anything that has ever come next as an option by having it maybe very high? So that's top P. Now these green bars that I mentioned, they're showing the probability, the chance that the computer is going to choose that word. And as you can see, they're not all the same. The bigger the bar, the higher the chance the computer is going to pick that word to come next. And how does it set these bars? That's controlled by this value here, the temperature. Now, with a high temperature, it's going to give all of these candidate words a chance. Now, it does have, you can see it's got a higher chance of picking the more common words, but they do all get a chance. But if I lower the temperature value, I'm reducing the probability that these less common ones can get picked. As I lower the temperature value, the more common words are increasing in probability. And if the more I lower the temperature value, the more common words are increasing in probability even more. So I'm increasing the chance that the computer is going to pick one of these more common words. So how, again, it's kind of a decision I need to make of how do I want the computer to generate new text? Do I want it to almost always pick the next word based on what came up most often in my documents? Or do I want it to sometimes pick a word that's a bit more unusual, a bit more creative? Do I want a bit more randomness in there? So top P controls which of the words that we've seen come next before can be a candidate when we're choosing what's going to be the next word. And temperature, where we've got a lot of candidates, temperature is going to control how often we pick one of the unusual ones, one of the less common ones. I'm going to leave them both high for now, and I'll come back and play with them and change them a bit in a moment. So I'm going to give it a try. I'm going to give it a word to start from. I'll go with the, because I saw that the was in the documents I collected, I forget how many times, 1,600 and something, wasn't it? And each time it was followed by another word, and I saw some of those when I was scrolling through the list before. Those words I was scrolling through they're the options that the computer can choose from for what can come next, based on this temperature and the top p-value that I've told it to use. So I'll click on generate. The forest directed at risk from the Great West. This is not great. I mean, if you don't look too closely, it looks like it's generated text, but let's look at what it's actually done. The first word it generated was forest. So remember, the came up in the documents 1,696 times. And there were 747 different words that were found after the word the. Forest came up 3 times. So there was a really low chance that forest would get picked, less than 1%. But this time, because of random chance, this time it did get picked. What was the next word that was picked? Directed. So directed was chosen because we were looking at the word forest. So forest was in the document 6 times. 5 different words came next. Directed was one of those, and it came up just once. But with only sort of 5 options there was a 17% chance that this was going to get picked. And I can go through and look through for every word. I can see why it was picked based on what it had seen before. Now this is producing very random. Actually, but I should sort of say that there's a lot of randomness in this, right? So if I just click generate again, I'll get some different text from that same starting word. Each time I hit generate, I'm getting different text. Eruption. I was looking at that before. So I remember seeing that that came up 747 times, but it followed the word the 34 times. So there was a 2% chance roughly that it was going to get chosen. But anyway, so this is giving me quite random text and text that doesn't really make much sense. So remember these values I was looking at before. Let me go back to that top p value and I'm going to move it all the way down. I want a really low top p. I want it to only choose the most common word that came next. So let me try that and hit generate. Now that's not great. It's less random. By reducing the list of candidates so much, there's only one choice. So you can sort of see here, or maybe there's a, yeah. So if I look at the word of, there was a 100% chance it had to pick the word of coming after summit, because I'd left it as the only option. I can see it picked summit. There was a 100% chance it was going to pick summit. By reducing the list of candidates so much, quite often there is only one choice left for the model to make. So it ends up going in this loop, the volcano summit of the summit of the volcano summit of the summit. I've reduced top P too far. Let me increase it a little. Very slightly better, but still repetitive. Let me increase it again and hit generate. Getting better. The more I increase top P, the more creative, the more varied it's going to be. The more I reduce top P, the more I'm controlling the number of options it has. And I can use temperature for this as well. If I reduce top P again, this is still picking quite random words. So remember that temperature value is how often it picks less common words. So if I reduce temperature as well, oh, we're back to being in a loop again. So let me increase the temperature a bit. Still too restricted, still in a loop. So I can play around with this, and I could give it a different starting word as well. You know, if I give it a starting word of volcano, I'll get some text. Let me give it some more options. That top P is way too low. So this is starting to look a bit more like sentence. The text still isn't great, is it? Remember that context window idea that I was talking about earlier on? By looking at only one word when I'm choosing the next word, it's really difficult to make an informed decision about which word to pick. And modifying the temperature and top P is helping me a bit, but it's not really helping me with this core idea that I don't have much context. So let me go back to that decision. As a quick aside, to try and explain what I mean by context, I remember when my kids were younger, we used to play this game called Consequences. It was a drawing game. You would draw a bit of a diagram, normally like a bit of a person or a bit of a monster or something, and then you'd fold over the paper before you'd pass it to the next person. And then they'd draw the next part of the person or the monster or whatever, and then they'd fold it over and pass it to the next person, and so on. Each person doing the drawing can only see the last tiny bit of what you've drawn, enough so that when they draw something, it's connected up to yours, but they can't see what you had drawn. Without enough context to know what has come before, they're adding something to the drawing that doesn't make sense, and hilarity ensues. I'm not sure if this game is played outside the UK. I'm probably not making it sound right. It is better than I'm making it sound, honest. But I mention this because this is the kind of thing that we're doing here. It's trying to do something without the context of knowing what's come before. So increasing the context window can help. So I'm going to go for the middle setting now, and then click on next. And now the computer has counted every two-word sequence in the documents that I collected. So the most common pair of words was the volcano. And the volcano came up 68 times. And of all those 68 times, what came next? What was the next word after the volcano? And 19 times it was apostrophe S. I should say, tokens aren't always words. A token isn't always just a word. Sometimes a token is a bit of a word. So the volcanoes with an apostrophe was found 19 times in my documents. 10 times the volcano was the end of a sentence. 3 times the next word was and. The volcano and shows up 3 times in all of these documents. So what I've got now is a list of the possible options to choose from for what word could come next after every 2-word sequence. And again, I can use temperature and top P. You know, top P decides what candidates I've got. You know, which of the words that came next could be a candidate, and temperature controls how often we pick one of the less unusual, one of the unusual or less common ones. So let me make them high again and hit next. So I'll go back to the as my starting word and hit generate. Oh, I need more than one word, don't I? Because it needs, it's looking for what comes next after a 2-word sequence, so I need to give it a 2-word sequence. So I'll go with the volcano. So what have I got? And remember, like before, every time I hit generate, I'll get some different text because there's some randomness in here. So this is looking a bit better. You know, it's still not sensible, but the increased context is helping. And like before, I can click on words to see why it made these choices. So in this point, it's saying the arc forms the southern slope. And it's because the southern showed up 8 times. There were 7 different things that came after it, and slope came after the southern twice. That meant there was a 1 in 4 chance, there was a 25% chance that it could pick that word. Previous records using the ANAP trail, not knowing of its eruptive history. When you click on a word, look at the fact that it chose the word history. The only words that went into that decision were it's an eruptive. By clicking on history, I can see that it used just it's an eruptive to make the decision of history coming next. The fact that the sentence started with a mention of the ANAP trail, the fact that it was talking about previous records, none of that was used. It only used these 2 words in grey to make the decision of this word. This short context makes it difficult for this model to create longer sentences that still make sense, because by the time it reaches the end of the sentence, it is not still keeping in the context where that sentence started. So let me increase the context a little more. I'm going to change it up to 3. Actually, if I review that so I can look at some of the numbers, the numbers are much, much smaller now. So I can see the most common 3 token sequence was the volcanoes. And what came after that was summit 3 times. What came after that twice was slopes, and so on. You know, the volcano slopes came up only twice in all of my documents. You know, some of these sequences, you know, the volcano's base only showed up once in all of my documents. The volcano's geometry was found just once in my documents. It's going to be really hard to find patterns or useful patterns in this because I haven't given enough documents to find useful patterns with such a long context. So the more I increase the context window, the better text the model can generate, I hope. I mean, I haven't tried this one yet, but the more we increase the context window, the better text it should be able to generate. But really, the more and more documents we need to feed it for this to be useful. Let me go with the volcano is. Let me try this out and hit generate. So this looks much more sensible, like text. You know, the airport reopened the next day. I can see bits in here that actually look like sensible English. But if I look at, you know, why it made some of these choices, it had only one option here because it had only seen air, end of a sentence, stop, it only saw that sequence once in all my documents, and after that came airport, so it just had to pick that. And if I go with why did it pick reopened, it had only seen that once. If I go with essentially what it's doing is it's just reproducing sections from the documents that I collected. There aren't enough examples of what I'm trying to generate for it to have patterns to generate anything new. Now, the next step could be And if I was going to carry on with this project, my next step would be to go back and add more documents, find more text about volcanoes, add it in, whether from Wikipedia or other sources, or I could write some more stuff myself. And hopefully that would help improve. You know, the more examples I can find, the more useful patterns, it would actually start to generate some more original text instead of just doing what it's doing now, which is reproducing chunks of the original documents. But in the interest of time, I'm going to park this project for now because I want to show you another one. Before I move on, let me do a quick recap. What have I shown? I've shown that to create a toy language model, you start off by collecting some documents, and the computer looks for patterns in how tokens follow other tokens in those documents. When the computer's found those patterns, you then get a decision to make about how you're going to use those patterns to make choices. The size of the context window, the temperature, the top P, and so on. And then once you've made those choices, the computer can start generating text. And it does this one word at a time. It generates the next word, and then the next, and then the next, based on the patterns found in the input documents and the decisions you've made about how to use those patterns. That's a toy language model. Let's move on to a new project where we're going to configure a small language model. So I'm going to create a new project because what I want to show you is those kind of principles that we've learned. I want to show you those in action with a language model that's been trained with millions of documents. You know, helps us take a step forward. So I'm going to call this project Storyteller because I want to show another use case for student projects with language models, which is like a creative writing kind of activity. Again, I'm going to pick generating text and I'll store this on my computer. So, as I said, the good way to learn about language models is doing it in stages. So we've done a toy language model where you do it completely for yourself, really, really simple model. With a small language model, you get a language model to start with, and then you get to control configuring it so that you can see those kinds of principles applied. But with a language model that has been given millions of documents, so you don't have to go through collecting millions of documents yourself. So, model architecture. So essentially, you know, there is no shortage of teams and companies producing language models today. Now, I've got 6 models to choose from here, from the very small at the top, small LM2 from Hugging Face at a minuscule 276 megabytes, through to some quite small options like Llama. Meta's Llama is 711 megabytes, up to the not exactly small Gemma from Google at 1.5 gigabytes. It's good to have options to compare from because I find it super interesting to compare how these different models perform, and it's fun to experiment with putting the same prompts to each of these different models. Another good reason is for students who might have limitations on network speed, download speed, or just disk space. It's helpful to have different size options to choose from. I'm going to start with this smallest option. So I hit download. Now that looked very quick. I should say it's only this quick because I've used these models before. So they're already downloaded to my computer. The first time you use a model, you're going to need to wait for it to download. And how quick that is will depend on your internet connection. Plus, you'll need enough disk space to store it. So keep that in mind if you're doing this on something really, really small or on a slow network. So I picked my model, the smallest of the options that I had. Next, we're back to context window again. Now, remember when I was creating my toy language model, I had a really, really tiny context window of just a few words. And remember I showed you that each new word it was picking when I was towards the end of a sentence, it had no consideration of the words that were at the start of the sentence. And that meant I was creating sentences that made no sense. Now, these models are much more complex, so they can give me much, much bigger context windows that go into the thousands. And when you've got a big enough context window, it's going to be choosing the next word, not just based on the words in the current sentence, but all the words that have come before, the words in your question, the words in the last answer that the computer gave you, because that's how chat interactions are possible. When you're asking a follow-up question, your last question, your last answers, all of that can fit in the context window if it's got a big enough context window. I'm going to start with with a pretty small context window of 512 tokens. The next decision, we're back to temperature and top P. So remember, temperature is how is the randomness. It's how it's choosing which word. With a low temperature, it's going to pick something that it's going to prefer the words that were most commonly found in the past, the ones that are the most probable. With a high temperature, it's going to do something a bit more unexpected. It's going to pick something a bit more random. It's going to be a bit more creative. And with top P, it's how many of the words that have come before are candidates. With a low top P, you're choosing from options that are most common. Oop, I didn't mean to scroll. So now I know I said I wanted to do some creative writing, but let me get back to that in a minute. I'm going to start by testing it with some general knowledge questions. I'm a big Marvel Comics fan, so let me try. Who were the founding members of the Avengers? That's pretty terrible. Let me try that again. I'm going to reset the context, start with a new context and try again. Well, that's interesting to see Chris Hemsworth come up, James Tiberius Kirk. So it's being creative, but it's getting really far off track. I'm asking the model to generate new text, and when it generates statements that aren't true, we call these hallucinations. And this is a problem when we use language models in the real world. Now, remember what I said about temperature. Temperature is controlling the randomness in text generation. With a high temperature, I increase creativity because I'm increasing the chance that it's going to choose less common, less likely words. But this is too uncommon. So let me try and reduce the temperature. And actually, I'm going to reduce the top P as well because a lower top P will limit the next words to the ones that are the most likely and the most probable. And reducing this is helpful when you're doing factual type things. Actually, I'll start by reducing it a bit, and then I'll sort of see the difference it makes as I reduce it more. So I'll reset that and start again. Who were the founding members of the Avengers? So this is getting better. You know, I've got a reference to Captain America and Tony Stark, and so we're getting better. I mean, I can sort of see where, like, Nova was in the comics. So there is a link between, for example, Nova and Iron Man. So it's not completely off the wall. It does make sense that in some documents about comic book characters, about the Avengers, they will have seen mentions of that. So I can see where it might pick that. But still, I want it to go for the more common choices. So I'm going to reset, and so we're getting better now. Formed in the 14th century. Nah, still not great. Let me try again. The more I reduce the temperature, the more I reduce the top P. The creativity is reduced, the randomness is reduced, and hopefully we'll see better, more factual answers. That's getting better. Captain America, Thor, Black Widow. Let me go all the way down. Let me go all the way down to the bottom, and let's see if that helps us. It's turned the Avengers into some sort of family affair. Let me try that again and see what I get. It's really getting stuck in this family idea. If you reduce temperature and top P too much, you restrict. I mean, sometimes what you tend to see happen is it starts repeating itself, which is kind of a little bit what it's doing here. Sometimes you see it get in a loop, like I saw with the toy language model. Spending longer with questions on Avengers than I was planning, but this is interesting. Let me try, instead of keep resetting it, let me try with a follow-up question, because it brings me back to that idea I was mentioning about the context window. If I say, those don't all look right, I'm interested in the characters in the 2012 movie. Now remember, because it's going to have, oh, that's, so I think what's happened here is I've run into the limit of uh, of the context window, because ideally what I want it to do is to still have my original question of the Avengers, and it must have still had that because it referred to that, but it's running into a limit of being able to generate new. Let me try it one more time. In the Marvel Cinematic Universe, who were the founding members of the Avengers? Let's see if that helps. That's. Let me try with a larger context window. Um, I'll try it. Actually, I'm gonna go with this. I'm gonna have a low temperature, a low top P, and I'm still gonna try with this idea. I'll try one last time with this idea of the Avengers. Who were the founding members of the Avengers? So that's better. I still don't know, not exactly formed in 1940, but okay. But apart from that, it's in the right ballpark this time. Um, I'm interested, oops, in who were the, I can't type today, founding members in the 2012 movie. And this idea of context window, so it's going to have the previous answer and my previous question still in the context. That hasn't helped. We're now talking about the Joker, which is great. Remember what I said about the choice of model. The larger models are more complex, they can give better answers, but they're much bigger to store, you need more disk space, they're bigger to download, and so on. So I am starting on the absolute smallest model. So actually, let me try with one of the bigger models and see. In fact, let me jump all the way to, I'll use Gemma from Google. And let's see if it will do better. And actually, I'll start with, let me start with a small context window again. I'll do one last try at my Avengers thing, and then I'll get back to my idea of a storyteller project. Who were the founding members of the Avengers? That's better. Oh, I'm getting some emojis in this one as well. And if I, sticking with this idea of context, so with follow-up questions, so if I try, were they the original members in the 2012 movie? Okay, that's interesting. Let me get back to my storyteller idea. So I'm going to reset this, keep with the small context window. Let me start off with a low temperature and top P. So I'm going to try something creative writing. So I'm going to say, I want you to tell me a story. So I'm getting a story about a ladybug named Lucy who met a caterpillar. Um, that's kind of nice. Let me try that again and see what I get. I get another story about a ladybug called Lucy. And again, the Lucy meets a caterpillar. So with a really low temperature, I'm reducing the randomness. So I'm going to get similar answers each time. Now, for factual questions, knowledge-based questions, that's good. You want consistent answers. You know, every time I ask who was in the Avengers, I want the same list of names. But for a creative writing task, it's a bit, I don't want the same story every time. Let me try it a third time and just see, do I get, yeah, again, a third time I get a story about Lucy, the ladybug. So, let me try increasing the temperature a bit. I'll increase it to half and the same with top P. I'll reset and then ask it, I want you to tell me a story. Now I'm getting a story about a firefly named Flicker. Still mentioning the ladybug, so obviously there's something there about. And the model is off now. Let me try and do this in stages. So I'm going to reset this one last time. Actually, let me make it more creative. I'm gonna go for full. I want a super creative story. I want to not restrict it to stories it's seen before. I want it to go in any direction, pick any word that could possibly be a candidate. But this time I wanted to do it in stages. So I'm going to say, I want you to tell me a story one sentence at a time. When I'm ready for the next sentence, I'll say next. Then you should continue the story. Okay. So starting off with something about ladybug again, but okay. Next. It's interesting. This model does like to give me emojis in the answers. I wasn't even sure they could do that. Discovered a bee buzzing around a flower. Next. So this is essentially doing what I want. It's not going in circles. It keeps giving me a new part of the story, which is all good. I'm gonna now. I think it's likely that it's. Oh, that's what do you? I think again I've bumped into the limit of the context window because I'm giving it such a small window. Like now, my original actually. So this is worth saying. So if you scroll up, you can see where things have dropped off the end of the context window. So it no longer has my original question. It no longer knows that I was asking it for a story one sentence at a time, which makes sense where it's no longer knows I'm asking for that. It's got stuck. So this would have been better with a bigger context window so that it can still keep my original prompt in mind. I'm going to need to type that thing again. One sec. Sentence at a time. When I'm ready for the next sentence, I'll say next. Then you should continue the story. Live demos are terrible, aren't they? With a bigger context window, it shouldn't lose track of my original request. And you can check that for yourself. By scrolling up, you can see what you're seeing in this window is everything that still fits inside the context. So as previous prompts and previous replies drop off the end, you'll see it vanish from the top here. But now I've given it such a big context window of 16,000 tokens, I can take this story as far as I want, and it should be ages before it starts to run into troubles. And actually, let me sort of wind this up. I'll say, bring the story to an ending soon. Make it a nice ending. There we go, and they become friends. This hopefully gives you an idea of the kind of thing we could do in Scratch. So you can see this button down here. I can take this model, so this model that I've chosen. So in this case, I'm on Gemma with Google with this config, and I can load that into Scratch. So I can start making a creative writing project in Scratch. I won't go through in huge detail, but I'm going to use that same idea that I just showed you. So when you press the green flag, it will clear any previous context. It will, actually, have I still got to save me typing that again? I'll copy this into here. And you can see I'm going to leave the temperature and the top P on high because I want it to be a creative story. And then what I'll do is when I press the right arrow, I want more of the story. So I'll give the model, I'll say the word next to the model every time I press the right arrow key. So I'll submit next. And when I want it to finish the story, I'll press, what shall I press? I'll press the down arrow. Down means finish the story. So I'll say, and actually let me copy that from my practicing here. How did I phrase it? Here we go. And I'll put that in there. So when I press the green flag, it'll start the story off and it will give the model the instruction that I'm going to use next as a way of continuing, and I can submit next by the right arrow and then end the story with the down arrow. So let's give this a try. So this time we've got a story about a bunny named Timmy. Fantastic. At least we're not on ladybugs again. So if I press the right arrow key on my keyboard, I get the next bit of the story about Timmy the bunny, and I can keep pressing next to keep getting more of the story. And interesting that it's still using emojis. I'm not sure if that's unique to Gemini because I haven't seen it in many of the other models, so I think that might be. I'm going to get distracted just reading this story now. Let me bring this to an end. So I'm going to press the down arrow key this time. And the story ends with Timmy becoming a butterfly enthusiast, which is amazing. So let me wrap this up, right? By configuring, testing, playing with small language models, it lets you see those kinds of principles from the toy language model in action for real, but on much larger models. Now, these small models are still not as complex or as sophisticated as the large language models that you get in cloud services like ChatGPT. They will make mistakes. You saw me struggle to get a sensible answer about the Avengers. I got close towards the end, but I actually, I think that's useful. I think it's really useful to see that these technologies aren't infallible. They do make mistakes. They hallucinate. They make stuff up. And when they do make stuff up, it's hard to tell that apart from when it's giving you facts, because in both cases, it's just generating the next new word based on patterns of what words have come next in the past. The next step in this journey would be a large language model. Oops. But in the interest of time, I'm just going to sort of show you the start of that, and then I'll wrap up because this video is already far too long. So my last project was this, the large language model, because the next step is downloading a much bigger, more complex model and running it for yourself outside of the web browser, because then you get even more control over it. But the link to that is there. So my goal for all of this was to give you a simple introduction to language models, which is they're one of the most widely talked about forms of artificial intelligence today. I've gone through how you can play around with the ideas and the principles behind these technologies for yourself, how you can do that in this kind of educational tool, and how you can then jump into Scratch and start making things from that. Please do give it a try for yourself. I really do think it's the best way to learn and to understand. And you can try everything that you've seen me do here for yourself at machinelearningforkids.co.uk. Thanks very much for your time.